Hi, welcome guys, good evening. So this is going to be the review for part 2 of our Chapter 8 test. Chapter 8 went fantastic. Really kudos out there to everybody that took the test, that's watching this video. Couldn't be more happy, honestly, with the results. And so let's keep this train rolling to start out the second semester really well. Factoring is going to be a little bit more complicated for some of you. Okay, that's where we're going to reach out. We're going to have to try to make sure we get this down. So the first couple things, remember the order of the test that's going to go. It's going to go in this exact same order, but the questions are going to be different. Okay, so the first thing is just factoring. So we just need to find the greatest common factor. And if you guys remember, we did our factor trees. Now I'm going to do a factor tree on this first one, but not necessarily on this second one. Okay, so what do these factor into? It'd be 2 and 5. You can't go any farther than that. And 8 would be 2 and 4, and then you could factor this down again to 2 and 2. And then we have 1 n here and 3 n's here. So technically, this could be written out as, and let me, I'll write it over here. It would be 2 times 5 times n, and it's going to be plus 2, 2, 2, and then it would be 3 n's, okay? And then what we talked about is what do they share in common, right? So we have 1 n here, 1 here, and we do have 1, 2 like that. And do they share anything else? Does this monomial with this one? No, they do not, okay? So all you do now is you factor them out, okay? We're taking things out of here. So we're going to take a 2n out. So I'm going to write it way over here. 2n is out. And then what is left behind? Well, if you do the circle method like this, you know what's left behind is a 5, and it's plus. And then what's left behind is here is 2 times 2, which is 4. And then we have 1, 2, n's. And that's it. That's your answer. Okay? Remember what we're doing for is trying to find the greatest common factor and just ripping things out. On this one here, off the top of my head, I can see, ladies and gentlemen, that the greatest common factor is going to be a 5. Okay? And it's also going to be, I'm going to use a different color, not to get you guys all messed up. It's going to be a 5. And then these here are going to be, this has 3 x's and this has 2. So the greatest amount of x's is actually going to be what? 2. Okay, so there's your common factor. Now, what is left behind? 5 divided into 10, you would have a 2 left. And then how many x's are left? It would in fact be 1x, okay? Because if you were to multiply this out, 5 times 2 is 10, x to the second times x, another x, would actually be x to the third. So hopefully you guys understand that. Plus, factor out of 5, what's left behind is another 5. We took all the x's, so it would just be this. If you multiply it out, it would be 5 times 5, which is 25, x squared. So we did it perfect, okay? That's the basic factoring, so please make sure you guys have that understanding. All right, factor by grouping. Now we're going to go a step farther. Okay, what we're doing is we're going to take and we're grouping this. This is the most difficult one for all of you guys to do. So I just want to make sure it's recording. This is the hardest one for you guys to do, okay? So what does this first group share? All right, they share a y, they share, in fact, a y squared, okay? You guys see, you can't factor anything out of a 3 or 5, but they do have a y squared. What's left behind? 3y plus 5, right? That's what's left behind. So my assumption is going to be is that I'm going to be looking for another way to create a 3y plus 5 over here. So what would I factor out of here? Well, what's the greatest common factor? Well, I know I can factor out a 2. So if I factor out a 2, what's left behind? 3y plus 5. Okay? Fantastic. Okay, now what kind of 2 is it? It is a positive 2, so you would put a little plus here. And ladies and gentlemen, that's it. Okay, now that's the factoring part. But are we done? No, we are not. The last piece of this puzzle is, remember, it needs to look like this. Okay, we need to make sure we get it in groupings. And in this case, since it's a y, it's going to be y. These are pluses, so I know it's going to be y plus something and y plus something. So that's our goal to get to. Well, the good news is we have one of these, okay? This is a duplicate, so we do have the back end here. So we do have 3y plus 5, okay? That is one set. Now, what is the other set? Well, the other set technically is a reverse distribution, okay? Some of you, when you solve these, you do what's called the distribution model, where you take an equation, you split it in half. So what's in the front here is actually this piece here, and then it's going to be plus 2. There's your answer. Okay, so can you multiply this out and figure it out? Yeah, you can. Okay, just make sure if I were to multiply this whole thing out, would I get this answer? So I have a 3, a y squared. If I did the FOIL method, the first term would be 3y squared. Bam, I got it. Okay, my next term would be y squared times 5, or 5y squared. I got it. Okay, move forward. 2 times 3y would be 6y. Yep, 2 times 5 is what? 10. I did it. Okay, make sure you guys can do this factoring by grouping. All right, this is one of the more harder ones to do. Now we get into factoring with the x method that we were using. Okay, remember what it is. Okay, for all of you guys that don't remember, make a bigger x. It is the factor was the b on the bottom, c on top. You remember what that was? Here's your equation. Okay, it was going to be, and I'm going to write it out: ax squared plus bx plus c. And technically up here, what I want you guys to start thinking about is it's always going to be a times c. All right, it's always a times c. The issue becomes, what is the a value for this first one? Well, the a value is a 1. So technically, does it matter? No, it doesn't, not at this point. So you'd put the c. Our c is 20. Okay, and then our b value is what? It's a 9. Okay, so what two numbers, okay, would multiply together? Now, the other thing would be the signs. We know this is going to be a plus, and that's a plus. It's a very key, important thing. Now we're set up. Remember how it goes. What two numbers multiply? So I'll put on this multiply here, and then they would add here. So multiply and add. So what two numbers would they be? You can do a breakdown if you want. Okay, I'm only going to do this one time. So your numbers would be 1 and 20, of course. Add those together, you get what? 21, that's not it. 2 and 10. Add that together, that is what? 12. Does 3 go into here? No. What about 4? 4 and 5. 4 times 5 is 20. If you add those together, you would get the number 9. So, ladies and gentlemen, that is my answer. And so what it says here, factor it out, it is x. It's going to be y plus 4, y plus 5. All right, that is your setup. This key piece is what you guys need to remember, okay? Technically speaking, this would be like 20 times 1. Do I need to put the times 1 in there? No. But if you want to start writing that, you can, okay? Factor out the next one. Same thing, okay? Now, here's the difference. We had talked about before, making sure you guys understand. All right, what number's on top? 16. What goes down here? It's negative 10. It's 1 times 16, because remember, it's the AC. So if I were to slide a 1 over and put it in, does it make a difference? No, it doesn't, okay? I want you guys to get used to that thinking. When we taught it originally, I didn't teach it without the A. I want to kind of do that going forward. What two numbers would multiply? Well, I got a negative here, and I have a positive on the back side. So what's going to happen is if I have a negative number here, I know I'm going to have at least one negative. The question is am I going to have 2? Well, in order for this to be positive, it's actually going to have to be 2. Remember the rules, okay? If it's a minus plus, 2 negatives are going to equal a positive. So remember, this is multiplication. So if this is a positive number and you have 1 negative here, you've got to have another negative, okay? 2 negatives equal positive. So what would they be? So let's think. 16, we can break it down. It'd be 1 and 16. Add those together, it's a 10, okay? That's not going to be it. 2 and 8. There we go. 2, if it'd be negative, that's your setup. 2 and 8. So my answers, ladies and gentlemen, are y minus 2, y minus 8. Pretty simple, okay? Next one, number 6. First thing you guys need to do, which we haven't talked about yet, is to see if there's a greatest common factor, okay? On our notes on chapter 8.7, I give you a table, okay? The one table I need to print out. I really wish I did, but I don't have it up. I'm looking because I'm wondering if I have space where I could put it, which I do have a couple poster board areas that I could do it. One big key thing is, can you factor anything out? Well, I know I can do a 2 here because these are all even numbers. Can I do a 6? I bet you I can. So if I factor out a 6, what is left behind? W squared minus 6 divided by 11 would be 60. It would be by 66 would be 11. Sorry, minus that would be 10, right? Because 6 times 10 is 60, plus 2 more would be 12. So, is this easy to solve? No. Is this easy to solve? Yes. Okay, now you set your factor up. Negative 12 and negative 11. So in this case, if I know I'm multiplying and creating, okay, a negative number here and here, I know I'm going to have a positive here and a negative. So I'm going to be subtracting the numbers from themselves. What two numbers would multiply together to make 12, but when you subtract them would be 11? Well, of course, that would be 1 and 12. Okay, so it'd be 1 minus 12 would be negative 11. Multiply them together, you get negative 12. So my setup, your answer is going to be 6w plus 1, w minus 12. Now here's the problem. Some of you will want to multiply this 6 back into like one of these equations and make it 6w plus 6. Is that answer correct? Technically it is. The problem is it might be marked wrong in Alex. So please make sure you factor first, okay? Big key thing. Look at the different terminology here. Factor, factor completely. So we know completely means we're going to have to rip something out first. All right, starting number 7. Can we factor out a greatest common factor? No, we cannot. Nothing shares. Factor out of 3 is the lowest, but 3 can go out of here, but it can't go out of 5. So we just add it straight up. So we had talked about before, a times c over b. Okay, remember, this is ax squared plus bx plus c. So what are my a values here? Okay, if you guys do the setup, it's going to be a times c. So we're going to slide this over to here. So it's going to be 15, right? And then your b value is 16. So it's a plus plus. So I know I'm dealing with two positive numbers, which makes this so much easier. So what we have now is we have to figure out what number multiplies together to make 15, but when you add it, make 16. Of course, the answer is going to be 15 and 1. Okay, so here's where it gets tricky. All right, we have to remember, are we done with anything here? And the answer is no, because if you guys just create an equation that looks like this, okay, so if I drop this down and go x plus 15, right, x plus 1, what you would have is that you are missing the front 5. Okay, that's the problem. X times x is x squared. Where's the 5? We're missing it. So remember, there's two methods that we had talked about. It's either the bottoms up, where you bring this over to the bottom. So you would take the a, divide that by 5. Okay, just that last number. Or, remember the other setup, is to bring the a in. So instead of having it written like this, it would be 5, because it's the original a, x plus 15, and then it's going to be 5x plus 1. Okay, those are your two options. Now, ladies and gentlemen, you simplify accordingly. So one thing you do on this one, can you divide this out? The answer is what? Yes, it is. 15 divided by 3 is 5. Okay, there's your answer, x plus 3, right? Now this one here, can you answer anything here? The answer is no, this is not divisible. So you do what's called the bottoms up. If you guys remember, you take the bottom number here and you bring it up into here. So your answer ends up being 5x plus 1. And that's your setup. All right, remember the factoring method? It's the same kind of principles and philosophies. Okay, can you factor anything out of here? Yeah, you can take a 5 out. If you factor a 5 out, you just throw it away. What's left behind? X plus 3. And we already have this, and we can't factor that, 5x plus 1. So we talked about the different benefits, but just remember that we get the same result, okay? Remember what this would be? This would be 5x plus 3, but we just get rid of the 5, okay? All right, next, number 8. Can you factor anything out? The answer, of course, would be no, you cannot. So let's go and do our methods here. So I'll do the bottoms up on this one. All right, so first step, slide it over. It's going to be 10 on top, negative 7. Once again, we're running into a negative here, but a positive number. So we know that's going to be positive on top is going to be double negatives. Okay, multiply it out. What two numbers would multiply together? And then when you add them, make 7. It's going to be 2 and 5. 2 times 5 is 10. Both negative. If you add both the negatives together, you get negative 7. So now, ladies and gentlemen, I'm going to do the bottoms up. So it would be 2z minus 2. Actually, whoops. Bottoms up is not that method. All right, it would be z minus 2, and then it's going to be z minus 5, right? And then you take the bottoms up. So you take this 2, you move it down here. So divide by 2, divide by 2. Can you simplify this? The answer, of course, is what? Yes. All right, this would be z minus 1. So it would be z minus 1. And then this answer right here, ladies and gentlemen, can you simplify this? No. So you take this up here. So it's going to be the number 2z minus 5. Let me back up, make sure I wrote that. Hopefully you guys can read that, okay? If you have any questions on this, please come see me in class, okay? But hopefully you guys understand the two methods. Now number 9, okay? Number 9 is going to deal with trying to say, if you ask yourself, well, there's something missing here. Yeah, there is. It's going to be a perfect square, okay? So you have to remember that there's 3 aspects of the functionality. First thing is find the greatest common factor. All right, look and see if it has one. Number 2 is look for a perfect square. Okay, ask yourself, can you take the square root of the first term and the second term? If you can take the square root of the first term and the second term, then you know you have an issue there. All right, and then the third thing would be if you can't do any of those, then you would solve using the AC method, okay, or what we call bottoms up, right? So solve using the AC method, which is the bottoms up, the distribution method, whatever you prefer, okay? All right, so remember what aspect I want to make sure you guys understand. If I were to write, so I'm going to go a little bit off track here. If I go, here's our equations that we're working with. AX squared plus BX plus C. Okay, what do we have and what are we missing? Well, we technically have the A value because it's the squared. So this is the A, and then we have the constant on the back end, the C. What we're missing is the B. Okay, so one really simple way to kind of look at this would be to see if you guys can actually do the AC method if you struggle with it. But let me get back to that. The first thing I want to make sure you guys do is ask yourself, can you find the perfect square, which means can you take the square root, okay? Can you take the square root of this? Well, square root of 25 is 5. Square root of x is what? X. Yeah, you can. Or x squared is x. And then can you take the square root of 49? The answer to that would be what? Yes, square root of 49 is 7. So ladies and gentlemen, you are done. There's a rule that talks about perfect squares, that this is how the answer would go. Now, if you get confused and you can't do this method, let's talk about, so this is the answer, okay? Hopefully you guys understand. Check to see if you can take a square root of the first term, square root of the last. If you can, you just write it, 5x plus 7, 5x minus 7. All right? The reason we do that is because it's going to get rid of the middle piece. So, and what the middle piece is what we're going to talk about real quick. So let me go back to what I was talking to you guys about before. All right? So what you need to think, if you can't think of it like that, is think of it like this. This is ax squared plus bx, this is standard form, plus c. This is my a, this is my c. What are we missing? We're missing the b. So technically the b is gone, the b is a 0. So some of you might be able to go like this and say, okay, what number goes on top? Would be a times c, right? It's a very big number. If I were to get a calculator out, okay, I would go 25 times 49, okay? If I did that, I'd get 1225, right? It's a huge number. And then what is my b value? Well, I don't have it. My b value is 0. And so what I have here, and this is a negative number, by the way, I have a positive number here and a negative number here. Okay, so this is just an alternative way to kind of think outside the box a little bit stronger. So I know I'm going to have two numbers that are exactly the same. Okay, so if by looking at this, if I were to go to my calculator and just type in like 15 times 15, okay, that's not even close. Let me go 25 times 25. Not even close. I got 625. Let me go 35 times 35. Ah, wow, that was lucky. The answer here is 35, and 35. And then you ask yourself, well, what do I do with that from there? Well, now you can technically do your factoring part. Okay, so what I mean by that is it would be x plus 35, and then it would be x minus 35. Now, everything I'm doing right now here, if you don't like this, you can fast forward the video. Just remember, if you can take the perfect square, we'd be done. Okay, but I want to give you guys an example just in case. Now, the bottoms up is the last piece, right? So if I take this and put it by 25, this by 25, because that's my A value. All right, what you guys could do is on these calculators here, you can put 35 divided by 25, and when you hit enter, you would get 7 over 5. So I know this can be reduced to x plus 7 over 5, and this would be the same thing, x minus 7 over 5. You can't simplify it any farther, so you take this up there. So I got the exact same answer. Okay, so can you use this method? Yes, you can. Okay, is it easier to do the square part? Yes, it is. Because here's the last one, number 10. It's also related to a perfect square. Okay, but it's a little different. So you ask yourself, can you take the square root of this term? Yeah, it's 5y. Can you take the square root of this term? You can. It's 4. And then you have to ask yourself, ladies and gentlemen, if you put a 2 and multiply this by 2, does it equal 40? Why? Well, let's test real quick. If it does, 5y times 4 times 2. 5 times 4 is 20, times 2, 40y equals what? 40y. So for me, I know that the answer to this then, ladies and gentlemen, is a simple setup. How this becomes about is it's going to be the square root of the first term, 5y, and it's going to be minus 4 squared. That is the answer. Now, another alternative might be 5y minus 4 times 5y minus 4. Once again, if you get confused and you do not like this method, you could see, can you factor anything out? And go the long way, okay? And when I mean the long way is by using this method right here, okay? You can do the AC, 25 times 16, you can put that number in here, subtract it by 40, and you get it from there. Okay, one thing I want to make sure is that you guys understand, here's your answers, okay? It's not that complicated because it's a perfect square. There are 2 rules that we dealt with on chapters 8.7. If you don't remember that, please pull out your notes and go from there. If you want to try the long way, you can. But that's it. Okay, I hope to have as much continuation and much success. One key thing, as we had on this for part 1, one key thing about part 2 is on 9 and 10, remember the square root options. Okay, try it, see if you can solve it. If you can't, use the AC method, okay, or this bottoms up method, whatever you want to call it. I have confidence in everybody. Tomorrow is going to be, because I'm filming this on Tuesday, we're going to do our review for Wednesday, and then we are going to have our test on Thursday. If you have any questions, please come see me in class. But ladies and gentlemen, I have faith that all of you will do just as well as the first time. Here's to a good Chapter 8 test. Till next time, I'll see you guys later.